if there was a place where you could see things like you've never seen them before? What if because you saw things in a different way, you made all kinds of breakthroughs in science right here on Earth? Well, the International Space Station is just that place, and it's open for business. Off the Earth, for the Earth. Hi, I'm NASA astronaut Tracy Dyson. Welcome to StationLIFE.
Houston on 2 for velocity calculation, assembly, steps 4, 5, and 4, 6. We're moving on to
Tracy,
step
you
5.
want to go right now for that activity?
Copy, thank you.
Okay, Tracy, we copy, and that's good information. We'll pass it along.
I'm going to let you in on something. While the International Space Station is a bold engineering feat and an awesome outpost in space, the coolest thing about it is that it's one extraordinary space laboratory. Several things that make the ISS a very special place for scientific research is microgravity, space radiation, extreme temperature exposure, both hot and cold, vast amounts of atomic oxygen, and an Earth observatory with a view like no other. In fact, the U.S. Congress designated the International Space Station as a U.S. national laboratory in 2005. This opened up the space station to providing opportunities for additional research from other governmental agencies, universities, middle and high school students, as well as private companies. In 2011, NASA partnered with the Center for the Advancement of Science and Space, CASES. This organization was awarded by NASA the responsibility of inciting the imagination of entrepreneurs and scientists alike for accelerating and facilitating space-based research, as well as creating public awareness of national lab research and making space science more accessible to the entire world. For more information on science on the space station, check out this video.
Our country has many national labs covering a landscape of scientific disciplines. The ISS National Lab is the newest of our nation's labs, and we can study things in space that we just can't study here on Earth. ARC-2 is our second suite of projects going to the International Space Station, with drug development, materials science, all the way into the life sciences where we could improve human wellness here on the planet. On this mission, we're going to launch a very interesting new piece of hardware that will significantly enhance our capability to conduct rodent research.
Now that the space station is complete, we can move into the utilization phase. And so NASA came to us and CASES came to us and said, look, this would be a great tool to be able to study bone density in microgravity. Can you develop it, and can you develop it quickly?
Until you get world-class hardware, you can't do world-class science. So what we're doing is we're enabling capabilities that they never thought possible on the space station.
A bone densitometer basically measures the amount of bone loss that the mouse will see up in microgravity. So if the goal and objective is to try to cure osteoporosis, think about it. If we have accelerated bone loss in space, and we have a control group of animals and a group that we implant with a drug, and we compare the two, we can see, is this drug effective at reducing or eliminating osteoporosis in the bones? Osteoporosis is very widespread, and I think this technology has a potential to have a huge impact on just the health and well-being of the older population.
The more experiments we get into space, the more public that is, the more people are going to realize that, hey, this is a very unique opportunity.
So many people have put blood, sweat, and tears to get the space station built. Now, let's make some great discoveries.
10 years ago, NASA was focused on completing the construction of the International Space Station. Now we're in the utilization era, and so we're trying to attract those innovative, non-traditional users.
Cobra has a long history of developing new technologies and being some real game-changing moments. From the very first baffler product in 1975 to putting graphite shafts in metals. We have to come to market with the right product. We cannot come to the market with something which is inferior. It has to be bigger and better and stronger than the previous model that we have. And this is just the next chapter.
Cobra Golf R&D is working with CASES to put an experiment on board the International Space Station that's going to investigate plating characteristics on metals to determine if we truly can make a better product. I would say almost anything that is made, anything where you'd like to be able to make a much more complex structure that you can't make here on Earth, huge leaps can be made in that environment.
Not only can Cobra Puma Golf learn something in microgravity about their golf clubs, but they also can take advantage of our seal, Spaces in It. The Spaces in It seal is a logo created by Casis that identifies the value of using this new environment to improve a product line or a service.
It's just flat out cool, and people understand that it's super high tech. And if you look at the golf club and can imagine all of the stuff that it's taken to get us into space is in that golf club, from a branding standpoint, I can't see a better fit. I really can't.
People have always been fascinated with space. It's the unknown. From the very first days of trying to put a man on the moon in the late 60s through to the International Space Station as it is today.
This is an exciting period of time right now where we have the opportunity to join with non-traditional users, not just researchers, but commercial for-profit companies to improve life on Earth and ultimately benefit mankind.
When you're up there for 6 months, or in Scott Kelly's case, an entire year, it's really the working in space part that becomes kind of the thing you love the most. It's the thing that gets you through the days. You're working with these professionals on the ground, and a lot of them have spent their entire lives working on these science experiments, and here we are up there and we get to operate them, and it's really an honor to get to do that. And in many ways, those are some of my fondest memories of being in space. You get to work these experiments, and they're usually watching over your shoulder from the ground. And there was a lot of times where I would do something, whether it was fluids or with flame research, it really didn't matter. The investigator would just say, whoa, wait, do that again. That was incredible and totally unexpected. And that was what just made you smile big up there when hey, we've been flying in space a long, long time, but we are still doing research that has unexpected results every single day on the space station. And I really love that about being up there.
Well, the gee-whiz thing is the zero gravity. Having a long-term laboratory with zero gravity is very unique, and I think it's one that I hope that we will reap the benefits from in the future from a scientific perspective in a much more active way.
As soon as the station was habitable, astronauts began to study the impact of microgravity and other space effects on the human body, other life forms, fluids, and materials. Over 15 years of continuous research and more than 1,600 experiments have been conducted on the space station. The space station is a state-of-the-art research laboratory that advances our knowledge of human physiology, biology, and material and physical science. This knowledge translates into medical, economic, and environmental benefits for the people of Earth. Outside the station, sustained by its large solar power supply, is a silent explorer sifting through space. Called the Alpha Magnetic Spectrometer, it is finding and tracking exotic particles of antimatter and dark matter found in cosmic rays from distant galaxies. The results could change our basic understanding of the universe. Other research aboard the station has led to the design and development of tiny microballoons, which will help get pharmaceutical drugs directly to specific cancer cells. The station is also used as an education platform to encourage and motivate today's youth to pursue careers in math, science, engineering, and technology. In addition, researchers aboard the space station will gain knowledge about human physiology, radiation, materials science, engineering, biology, fluid physics, and technology that will help people on Earth and enable future space exploration missions. There is no single place on Earth where a laboratory like this can be found, and in 2005, Congress designated the space station as an official U.S. national laboratory. This has opened up the station and provided opportunities for additional research from other agencies, universities, middle and high school students, and private companies. Scientists from all over the world are using facilities aboard the station. Several patents and partnerships have already demonstrated the value and benefits of space-based research. Future space station experiments and their applications on Earth are in the making, and the promise and possibilities are endless.
One aspect of the International Space Station program that makes it so unique is its international partners. 16 countries working together, combining resources to make the ISS the best it can be. Recently, astronaut Samantha Cristoforetti from the European Space Agency returned from her 199-day stay on board. Because the ISS is a working, active science laboratory, the crew on board puts in a ton of work every day. Let's see some of what Samantha was up to during her stay on the International Space Station. Of course, scientific research is the main area of focus on the ISS, but astronauts and cosmonauts, they have to live there too. Normal, daily, routine activities can be way different in space, and a bit challenging. Here's more on that topic from ESA's Samantha Cristoforetti during her stay on board the ISS.
Hello, and welcome to my hygiene corner here on the ISS. This is the place where I wash, brush my teeth, or after workouts, take a shower ISS style. The heart of the hygiene corner is the toiletry pouch, Comfort 1M. It's Russian made, and most crew members ask to have one sent up for them. It's really useful to deploy our hygiene items, and hygiene items come up in a Ziploc like this one. This contains supplies that need to last for 6 months. And they don't look much different from what your hygiene items look in your bathroom, probably. You can see a toothbrush here, toothpaste tube, deodorant. And as far as towels are concerned, we cannot wash stuff up here. So we get a supply of towels. Every week we get a towel like this one and a smaller washcloth. I usually take my new ones out on Sundays, so it's not quite time yet. I put those back. And for today, I will use the ones that I have already deployed for the week. Every second day, we can also take out a new, let's say, camping towel. It's one of those light towels. It comes in a foil like this, it's dry, and then we can add water, wet it, and it's really nice to clean your skin. In terms of brushing your teeth, it's actually very similar to what you would do on Earth. As I said, toothbrush and toothpaste look just the same, and you brush your teeth just the same. The only difference, of course, is that we don't have a sink to spit in when we're done, all that extra toothpaste. So some astronauts just swallow it. It's quick and easy. I personally don't like to do that, so I actually spit it in a towel. It's not the most elegant thing, but you have to do what you have to do. As far as soap is concerned, it comes up in pouches like this one. You need to add water, and then you get a nice liquid soap pouch, which needs to last for about 2 weeks. And it's a no-rinse type of soap. It doesn't make a lot of foam, and it doesn't really need to be rinsed. And of course, we do not have any running water up here, so we also need to fill up water pouches. We can connect pouches like this one to the water dispenser, which is in the nearby module in the US lab. And I personally like to fill it up with warm water when it's time to wash, but you can also fill it up with ambient temperature water. So I'll go ahead and do this right now, and I'll see you in a minute. Here I am, and I got my water. So first of all, I'd like to show you how water behaves in weightlessness, which is kind of interesting. Of course, it doesn't fall down like it does on Earth, and it kind of tends to stick to your skin because of surface tension. I don't know if you can see it. See, it doesn't really want to move away from your hand, just because of that surface tension effect. Now, of course, I put a lot of water on my hand just to show you. You wouldn't use all that water to wash, just because it's a little bit difficult to control. So I'm actually gonna dry it off. But if you have some time to take your time and be careful, you can do that, I think. I do it sometimes. I really put some water on my skin like that, just a little bit. And then I add some soap, like that. And then you can carefully go ahead and rub it. And it actually really gives you a nice feeling of cleanliness. And then, as I said, I like to keep my actual towels here dry, so you can use them to dry off. Now, of course, you don't always have the time to take it slowly and be so careful. So if you are a little bit more in a rush, let's say it's a work day and you had your workout and then you have to rush off and do something else, then you will simply, just squirt the water into your camping towel and add some soap, and that's a lot easier to control because you can just rub your skin like that. And I don't find it as pleasant, but it's certainly a lot quicker and easier to control. Now, all the water that you use eventually ends up in the towels that you use to dry. And we leave those towels close to a ventilation grate, like in this case you can see a ventilation grate right here, so that they can dry off. And all the water then is recuperated. It evaporates in the air, and then in the air conditioning system it condensates again, and it goes into our water recuperation bus, and it actually gets turned into potable water again. So we don't absolutely lose any of the water that we use to wash. Cutting your fingernails is not the easiest thing in weightlessness. Of course, you don't want to lose any pieces of nails around the cabin. So the best thing is actually to do it really close to a return grid of the ventilation system, so that all the pieces of nails that you cut off get immediately attracted, sucked towards the grid, kind of like this. There you go. And then when you're done, of course, you want to have a vacuum cleaner handy so that you can clean after yourself. And to wash your hair, we have a special no-rinse shampoo that requires theoretically no rinsing, but at least very little rinsing. So we just squirt water into our hair, we add some shampoo, we massage it just like we would on Earth, and then we kind of dry the excess water and shampoo off with a towel, and off we go.
Gravity, the question of gravity, and why do astronauts float around when they're in space? And it's not because the gravity is gone, it's because the spacecraft motion cancels out the relative effects of gravity that you experience. When you are in an orbit around Earth, you are in a continuous state of free fall, and this free fall is what nulls out the local effect of gravity. So imagine space station, and this is going to be exaggerated, space station falls 3 centimeters towards Earth, okay? It's closer to Earth, but at the same time, if it moves 3 centimeters out that way, its radial distance from Earth remains constant. And so you keep doing this, and you think of it as stair-stepping your way around Earth. So the result of this motion is moving in an arc around Earth at constant distance. So you're not really in zero gravity, you're still under the influence of Earth's gravity, but nominally we will say you're in zero G, which is technically not the correct way of saying it. So you want to refer to it as being weightless.
Progress cargo ship thrusters are boosting the space station.
Feel my speed picking up.
Okay, this time I'm gonna just let go the camera and see how camera moves.
I can really feel the velocity.
Yeah, you release the camera. Now it's all moving.
Losing control.
I'm not pushing. This is the acceleration from the thrusters of the Progress vehicle during the reboost.
See Koichi in the camera coming closer. Again, it's just due to the acceleration, constant acceleration. It's an 8-minute burn by the Progress vehicle. That means we'll have 8 minutes of constant acceleration. This pushes the space station into a higher orbit.
In this episode of Station Life, we learned how the International Space Station is an astonishing U.S. national laboratory and how scientific research is happening all the time. Some of the exciting experiments are fluid shifts in the human body, so we can learn how to take care of our body on deep space missions. Studies in bone loss that could help lead to treatments for osteoporosis, and joining forces with Merck Research Labs on protein crystal growth investigations, which crystallizes human antibodies that could help develop new clinical trials for the treatment of several diseases. As you can see, research on the ISS continues to benefit us all here on Earth. Be sure to stay in touch and follow us on Facebook and Twitter for the latest research news. And don't forget to download our new app on your mobile device. Until next time, we're working off the Earth for the Earth. And that's a wrap.